Hello, thank you for watching this video about graphing trig functions. In this particular video, we're going to be looking at tangent, just tangent, because it's kind of a special case. This also would apply for cotangent as well. The exact same procedure would be true. The difference would be your starting location for the first curve that you would draw. I will tell you that in this particular instance, we're going to have asymptotes. In fact, a series of vertical asymptotes for this curve. And I'll kind of show you, I know I don't have it listed anywhere in here, but I'll show you where those end up being. Okay, and they're pretty easy to find. Everything works exactly like it did for sine and cosine with one big exception, the period, pi over b. Now, some of you are asking, why is it pi over b instead of 2 pi over b? Some of you may still be wondering why it's 2 pi for sine and cosine, in which case I suggest you go look at the unit circle for both instances. In this particular case, how often does tangent repeat itself? Remember, tangent is y over x. In the first quadrant, y would be positive, x would be positive. In the second quadrant, y would be positive and x would be negative. So at that point, you've covered all the positive and negative versions of every single number. In the third quadrant, you'd have negative over negative, which would be a positive value. And then in the fourth quadrant, you'd have negative over positive, which would again be all the negative values. So again, every half rotation on the unit circle, you're going through all the values, positive and negative, that you could possibly come across. And then there's something that's really interesting that happens at a couple locations as you move through the unit circle in reference to tangent that didn't happen with sine and cosine, which is what's going to result in those asymptotes. Okay, so let's go ahead and look at a example. I kept this one pretty simple. The horizontal and vertical shift here, those of course would be in this instance are going to end up being none, right? There's no vertical shift or there's no horizontal shift. So I'm just going to write and the A are not applicable here. You can also write none, or you can write 0. Amplitude would be 4. And what you're going to see here in a second is the amplitude of a tangent doesn't really have a whole lot of bearing upon what the curve really looks like. It changes some of the details, but for the most part, it's going to be the same curve. And then the period here would be pi over 2. Right? Now, what I need you to do before we draw this first curve is I need you to remind yourself of what values for tangent are undefined. So that's any place where the x value is 0. Where's the x value 0 at? Well, the x value would be 0 at pi over 2 and 3 pi over 2. So at those half locations, we're having undefined values. So those are actually going to end up being our asymptotes. Now, the thing is, if we have a horizontal shift, of course, it'd move it and change those values. But what we'd end up looking like is we have a curve that looks like this. Now, I ran you through that because I want you to see why does it look like this and why does it go through the origin. I can draw that a little bit nicer, I think. Let me try that again. Okay. There we go. Okay. It looks a little bit like the cubic function in that its basic shape. The big difference here, and there's a huge difference, is that there's an asymptote right here, right? And another one right here. Okay. And the distance from here to here, we'll call this A to B. Distance from A to B is pi over 2, right? So if I wanted to mark these locations, this would be pi over 4. This would be negative pi over 4, okay? And then the curve repeats. No, let's try that again. There we go, okay? And again, the distance from location to location is pi over 2, which means that this location right here is 3 pi over 4. Okay, it's another half rotation for in this instance anyway. So what I did there is I added pi over 2 to pi over 4, so that's adding 2 pi over 4 to pi over 4, which is 3 pi over 4, and it just does that repeatedly over and over and over again. Now you say, well, what about the amplitude? What does that do? Well, what it does is it stretches it vertically, right? Well, I haven't made any markings here yet. Ordinarily, this location right here that we make some type of note about, maybe at in this case, what would that be? Say pi over 4 or something like that would be 1. Well, pi over 4 instead of, well, in this case, it's not pi over 4, but that quarter rotation, that's eighth rotation rather, would be a value of 1, but instead of 1 being 1, it's now a value of 4, right? The same 3 would be true down here. Now you may be thinking, well, what big difference does that have on the curve as a whole? It really doesn't. What it does is just stretches it up and down. So it's really a scaling factor in this particular instance. It doesn't have a whole lot of bearing on the appearance of the actual graph, which you'd have in extreme values instead of 4 or something like 10 or something like that. It almost looks like a straight line. It's kind of a diagonal. All right, and that's really the whole there is to trig, or rather tangent when you're trying to graph it. Horizontal shifts and vertical shifts will have the same effect as they do for sine and cosine. Nothing really changed on that, so I just kept it simple for this one. So if you want to know what that horizontal vertical shift does, go watch the sine and cosine curves graphing video that I've posted, and it'll tell you how to deal with the horizontal and vertical shifts. Thank you very much.